The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. It was huge. They were watching out for each other.
Hello, everybody. Thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kilauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, and so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Mauna Loa eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS-HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? It was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dane started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed, and we knew we were getting to the local community, and people were asking questions. So those were the best. I think I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well, and we got to a lot of people we wouldn't have normally gotten.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Lou Ettori today, in place of Dane DuPont, on our weekly HVERI Hawaiian Volcano Tracker. Today is Thursday, May 8th, 2025. How you doing today, Lou?
I'm doing pretty good. Another week, another eruption, or another episode, right?
Yeah, we actually had 2 episodes this past week since our last update was just shy of the main fountaining phase, so that's a little bit busier than usual. And so we'll cover all of that here today, and we'll try to do our best to fill in for Dane, who is away at a different engagement presently. So, yeah, we will be leading discussion on chat this week, collecting our questions as we go. We'll take a break partway through, as we have been in the last few weeks. And anything else before we get into it here?
You gonna hang with me for Community Corner tonight? You're gonna take your break.
Yeah, I'll try them. Yeah,
Nah,
I'm not sure I can read those names that fast as Dane, but I might give it a shot after I drink some water.
Right on.
All right, guys. So, okay, let's get our screen switched around here. All right. Aloha, everyone. This is our Hawaiian Volcano summary for May 8th, 2025. Over the last week, we had the main fountain phase of episode 19 and a full cycle of episode 20 of Kilauea's ongoing summit eruption. So you see on screen here the V2 camera of episode 20, but I'll pull us back to the B1 camera looking over the last week here, both day and night cycles that shows us both of those sequences. So starting off here, we had that first pulse of episode 19 that put a flow across the crater floor right there, covering about half the crater floor on the northern side. And then we had the second pulse from episode 20 coming closer to the southern side of the crater floor. And we have ooze-up flows occurring in between those 2 episodes as well as after episode 20 here. So pulling it back, episode 19. Let's see here. Here's episode 19 from the S2 camera. And what you can see is that precursory ooze-ups and overflows, and then a main burst of lava coming after that. That same episode 19 from the V2 camera. You see it here, a little bit more zoomed in. What you see is the north vent is the one dominantly active here. There is some activity from the south vent and some overflows, but pretty minor compared to the north vent activity, both in episode 19 and in episode 20, which we'll see episode 20 here from the S2 camera, with the south vent putting out a little bit of a flow before the main north flow overflows and high fountaining event. So that brings us back to the V2, which we started with, and there you can see once again the north vent overflowing with glow in between, some activity from the south vent, and then the main fountain phase coming in, lasting 4.5 hours for episode 20 and lasting about 8 hours for episode 19. If we look at our maximum fountain heights, they were both episodes a little bit shorter than previously. Episode 19 came in around 100 meters high, or 330 feet at its peak, and episode 20 around 500 feet, 200 meters at its peak. So that's in the same ballpark as our previous ones and higher than our lowest ones we've had recently. If we look at the greater patterns, we had 31 hours of overflows ahead of our shorter than usual fountain phase in episode 20. And we had a shorter than usual pause that preceded this as well. And if we look at this curiosity of the pattern, we've had these cycles of eruptions and pauses that have averaged over 20 episodes about 7 days, such that we've had many of our first overflows occurring on a Monday or a Tuesday, and onset of our vigorous fountains most common on a Tuesday. And we had that again this past week, getting back on cycle with episode 20 after being off on episode 19. Our 3-month tilt at Uekahuna, showing the swelling of the ground in between episodes, and then the depressurization of the ground during the high fountain phases, showed that same pattern again here for episodes 19 and 20. If you recall, our build up to episode 18 was longer than average, and we had a longer than average duration and drop in the ground tilt. And what you can see is that with a shorter with an average drop in episode 19 that allowed us less time to repressurize for episode 20, giving us only a 3-day pause and leading to this shorter than usual fountaining phase as well at 4.5 hours. And along those lines, we're seeing the pressure returning as the volcano repressurizes for the next episode, presumably episode 21, which the USGS estimates may occur within the next 3 to 6 days. Here that is right there. So the main hazard is still the VOG and tephra, including Pele's hair that come from the volcano. And fortunately, over the past week, we've had dominant trade winds. And so most of this material is being blown to the southwest, to the communities further away from the volcano, limiting the impact of this emission. If we look at the earthquakes over the last week, they've been fairly low still under the summit and continuing under the south flank and under Pahala, but at average or lower than average rates there. Kilauea still continues to be in a quasi-equilibrium here, with more or less the volcano stretching and contracting by equal amounts to maintain an overall level since eruption began in late December 2024. While in the Middle East rift zone at Pu'o'o, we still see contraction of the rift zone, suggesting no activity and no connection to the current eruption in that area closer to people. Here is the map most recently published for the location of these flows of events in the southwest and flowing east across this inner crater floor of Halemaʻumaʻu, right there. And on this eastern side, we're starting to see uplift of the ground as well from these pulses of lava injecting under the crust. This is the B1 camera, just over the last week, daytime views. And I'll just zoom it in to some of these foreground areas here where you can see crusts of the crater floor not being covered by flows, which there are some around, but these areas not covered by flows are still swelling up close to the edge of the flow there. So that's a complication that is changing our cycles to some degree here. And that's our summary for Kilauea. Quickly on Mauna Loa, things are very quiet still under the summit with very few earthquakes. In map view and in monthly counts here, continuing a pattern that's typical following the 2022 eruption. But the volcano continues to swell, rising upwards at the summit GPS station, which was a little flatter over the last couple months, shows signs of increasing here again. But in net, you can see from the current time to about 1 year ago, we've risen on the order of 7 centimeters or about 3 inches or so, even without all those earthquakes and other signals. So certainly magma is coming into the volcano, it's recharging and preparing for its next unrest. And that's our Hawaiian volcano summary for this week. So let's move on to our hazard summary. And we'll show you guys some cameras to start. Here is the S2 camera, just the daytime views showing the VOG blowing almost all the time here in the trade winds to the southwest. So there you go, that was how that looked. And similarly, we can look at the K2 camera, this tower view, and this one will have both daytime and nighttime views. So you can see when there's eruptions and glow, you can somewhat see where the gas is blowing as well. And likewise, it is blowing off over the Ka'u Desert for the most part, as you can see here. Day and nighttime. Here comes the second eruption, the second patch of glow. You see people walking out over here to the Oikahuna Overlook with flashlights occasionally, and that's this K2 camera time lapse. And stepping back even a little bit further to the side of Mauna Loa, here's Kilauea caldera, and there is the gas cloud before episode 19. And so let's play it. Here comes episode 19 with its bursts and blowing to the southwest over the desert. Lower gas emissions in between the episodes, and another puff of gas as those episodes begin, and once again blowing up to the southwest there. So that's our gas cameras, and we can look at the VOG measurement and prediction project for our forecast as usual. This is out of University of Hawaii and Manoa. And our dashboard forecast looks like this today for our SO2. So there is our emission source. Their value in here is 1,500 tons per day of SO2, which is about the average there. The USGS reported that between episodes 19 and 20, they measured 1,750 tons per day, so slightly higher, but in this very same ballpark. They said that during the gas pistoning events at the start of episode 20, they measured between 4,000 and 6,000, so that's about 4 times this amount. And they expect that during the sustained fountaining phase, the values were in a ballpark of 50,000 tons per day. And so now you're talking about, what is that? 20 times that amount there. So the pattern of distribution is the same regardless. So, but we really watch out for where the winds are blowing when that big puff of extra gas comes out at the start of each episode here. So it looks pretty good here. There's a SO2 blowing off to the southwest. We'll flip it to our particulate layer of sulfate aerosols, and now you can see a little bit more impact on the central Kona coast right there, as some of these gases get caught in this eddy almost, right, in this onshore offshore pattern that's common on the Kona side. So we can check in on our indices. Here's the State of Hawaii Air Quality Data website, and it looks green on all the values you see here. You do see on the Kona side some elevated values here, 50, so it's getting close to that yellow boundary, but not quite in that range. Here you can see the history of that station. So we like to go to our Purple Air Citizen Science Monitoring Network, which has more density here and shows us some extra values in here. So you can see all these extra yellows all through here and orange. There's one really high value here at 183. I'm not sure that has exactly anything to do with our volcano necessarily. It might be something else happening nearby there. It could be something like a fire or, anything that putting particles in the air near that very one lone site. But there's an 88 up there as well. So interesting to see what else is going on in Kona, but the volcano usually is registering these values that are more widespread across an area. So that's our purple air. And closer to the volcano, we're not having as big an impact because of these strong trade winds, which are forecast to continue over the next many days as well. So potentially in 3 to 6 days, when that next episode does come, we'll have trade winds still, hopefully, and also limit the impact of those emissions similar to this past week. So here's a national park monitoring site. They're showing a more northerly wind direction with a concentrated plume blowing to the south, away from people, away from the highway. So that's one of the best places for it to be. And they're showing 9 miles an hour, 4 meters per second as the wind speed there. And if we turn to our charts to look at the history of the national park areas, everything is looking in the green where the stations are coming in. As you all know, there's lots of construction happening in the park, so some of these sites are coming on and offline. So everything is in the green and looking good for anyone looking to go and visit the park. Looking at the satellite data, here's our windy.com SO2 layer. And so we've had a couple extra puffs of SO2 come out since last week, and they've added to this big orange cloud here that's floating in the atmosphere above the island. So this is higher up than we're breathing down here, but it's still detectable on the satellite here, lingering as part of this global cloud of this stuff that's flying all over the place here. And if we look at the Mounts project and the SO2 satellite captures, let's come back here to the 30th, before episode 19, and move forward. So there we see that very first puff of gas coming out. Everything's blowing southwest with the trade winds. And then first, we don't have very high concentrations in any of these captures. Here in a second, we actually catch a higher one offshore. So maybe in between these captures, it blew out, but the wind was so strong it blew it all the way over here before the satellite snapped the image. Right? And then it's gone on the 3rd, then the 4th, and our eruption episode 20 happened on the 5th. And actually, we might have not quite caught it here. We get a little bit here. Actually, this is ahead in time. So there's a little bit of that puff right there. And there is the remains of it way offshore, moving quickly the next day. It's a little bit different pattern and interesting to compare that to what we've seen before when it impacts people more and not as big an impact, and great to see and document that here today. So let's move on to our recent earthquakes. Here is our earthquake map showing the last 1 week of earthquakes here on the island, colored by depth. And what you might see is it's actually looking pretty light today. There's not a whole lot of dots on the map here. We have this one event up on northeast side of the island on the flank of Mauna Kea, 3.6, 20 miles down. This is one of these settling earthquakes as the volcano is adjusting, or the weight of the volcano is causing the rocks underneath it to adjust. And especially as they move over this zone of heat and away from the zone of heat, they expand, contract, or erode it. There's all kinds of things happening that redistribute the mass on the surface and allow these changes to occur. So that's that one. This other one here, deeper into Mauna Kea as well, Mauna Loa as well. We have one event on the flank of Mauna Kea, 1.9 adjustment between these two mountains. Pretty minor, really. A few deeper earthquakes in Pahala, the largest of which appears to be at 2.6. A couple of south flank events. The biggest one is a 2.2. And a couple of events on the summit, both under magnitude 2 here. So really quite slow on the earthquake front. We'll turn to our other website here and look at the wider picture for the last 7 days. So here we do show 3.6 deep under Mauna Kea, 2.6 under Pahala, 2.4, 2.3, a couple more 2.2s, that south flank one, and another one further north here as well, also 20 miles down. So that's just normal background for our island, basically. There's not a whole lot to dive into here. And that's likely because when a volcano has a way to relieve its pressure through eruption, it doesn't have to pressurize and cause as many earthquakes. So you still have them happening through these adjustments that are always always ongoing. They're not as intense as they might usually be. So those are our earthquakes this week. And we'll move on to monitoring to look at our signals and our volcano notices. So since we have 2 episodes this past week, we'll step through those in sequence here, starting with last week after we concluded our broadcast. At 10:30 p.m. last Thursday, the USGS put out a status report noting that the eruption had the onset of high fountaining for episode 19 at 9:28 p.m., beginning with 200 to 300 foot high fountains, 60 to 100 meter high fountains from the north vent, and preceded by 26 cycles of fountaining and overflows with draining as well. They noted that the cycles were about 10 to 15 minutes each, with about 10 minutes in between them. So they increase in intensity less than 3 hours before the sustained fountaining begins. And then you had those higher fountains of 100 meters or 330 feet right there. So after about 8 hours, 7 hours and 52 minutes, the high fountain ceases at 5:20 a.m. on May 2nd and covers about half the floor of Halemaʻumaʻu. And they note here, let's see, in here, somewhere in here, they note the amount of lava that came out. Maybe it's the following day here, but I believe it was 3 million cubic meters or 4 million cubic yards is what we had coming out from this episode. Go right there, just under 4 million cubic yards, 3 million cubic meters during this episode. So we'll fast forward a few days to Monday. Monday morning, they noted that episode 20 was likely to start in the next 1 to 3 days. They noted there was occasional spatter happening at that point already. They heard them glow in both vents all of the nights in between episodes 19 and 20. And coming to Tuesday morning's update at 10 a.m., they note that back the previous day on Monday at 10:48 a.m., episode 20 low-level precursory activity began. That's the pistoning, the cycles of lava rising and spilling over and then draining back in, and then rising and spilling over and draining back in. And when the first flow spills out of the vent and onto the crater floor, that is usually the start of the episode. So that likely was 10:48 a.m. here. So that was the activity here. They noted about 30 gas pistoning cycles occurring the day before, diminishing after 6 p.m., and then continuing with more pistoning after that. Many producing short flows and strong glow as well. So moving to Tuesday evening, they noted that at 5:28 p.m. on Tuesday, we had the beginning of sustained lava fountaining. The fountains quickly reached heights of greater than 500 feet or 150 meters, and fed flows crossing the crater floor, including a flow that poured over the south vent. So that was the onset of high fountaining in episode 20 there. And moving on, they note after 4.5 hours of fountaining, so this is lower than our usual, lower than our average, at just before 10 p.m., episode 20 ends its fountaining phase. And when this happens, the volcano starts to inflate again, suggesting that episode 21 will be forthcoming at some point in the future as well. So let's move from the Tuesday update to the Wednesday update, where they have a chance to report some more values. So they note that the south vent actually did have some fountains as well. They reached 20 meters or 65 feet. So it was active, but very weakly active compared to the north vent. Once again, lava covered about half of the crater floor. And just a little bit less, but similarly, about 3 million cubic yards, 2.5 million cubic meters of lava came out during that sustained fountaining phase. And so the last one was 4 million cubic yards. This one is 3. So about the same rate, more or less, right? We erupted about half the time, actually. So that makes a difference there, since we kind of erupt fastest at the start and then tail off as eruption continues with time. And along those lines, they noted here, they measured the output rate of lava during the first 30 minutes of sustained fountaining. And it was in the order of 200 cubic meters per second, or 262 cubic yards per second. So if you try to imagine what that might be, right? I'm not sure what that is in swimming pools and a typical measure here, but there it is in cubic meters, cubic yards per second. That was the first 30 minutes, and overall, over the 4.5 hours, it averaged 140 cubic meters or 153. Right? So that shows you how it's much higher to start, and then tails off as it goes on, and then averages somewhere in the middle there. This Wednesday update also reports the SO2 rates, as I mentioned earlier, those values during the pauses, during the gas pistoning events, and during the fountain events as well. All reported here. And we'll move to the Thursday update from this morning, where they say that episode 21 is likely to start in the next 3 to 6 days. Yeah, we still are seeing glow overnight in both vents, where we've recorded 1 to 2 microradians of tilt since the end of episode 20. We still have a tremor, and those are all the signs that we are seeing typically between episodes, leading to one more coming. And so it appears that that will be the case once again. So moving to the timeline here, here's a USGS timeline. They're now noting, you can see here, the beginning of precursory low-level activity as well as fountaining phases. And now they're reporting the episode lengths for the fountaining phases. So 4.5 hours for episode 20, 8 hours for episode 19, with a 3-day pause in between here. So we showed this in our summary, but once again, there it is. There's our 500 feet, 150 meters for episode 20. Our about 60 meters. I'm sorry, what is that there? A little less than, supposed to be about 100 meters, 80 meters here for 330 feet for episode 19. You can see there's a little bit shorter than 18, but higher than 17, which was our lowest one in our recent sequence. So yeah, we'll be curious to follow those and see if we continue to come down in value, right? Was this really our peak, or are we just having some adjustments happening within the volcano? And we'll come to this in a little while once again as well. So coming to our duration by episode, I try to simplify this, just show the red and orange. So that once the first flows come out of the vent, that's the orange length of time until the red begins. So you can see here our red was a little bit shorter, but our orange was a little bit longer in our buildup, right? Overall, the cycle remains on pace, more or less. The one that was abnormal, you can see, was 18, right? And what you can see is that since episode 14, this has been a consistent pattern. We've had lots of these overflows. Actually, you can see 12 had it, 13 not, but 14, 15, 16, 17, 18, all the ones since 14 have all had, to some degree, lava flows coming out ahead of the fountaining phase here. And you can see here this extreme value at episode 18, which is why in their timeline, they begin changing how they report things in episode 18. So you can see how they were forced into that there. And coming to this graph on the right, this is the same. All I'm doing now is adding the blue. The red and oranges are the same left and right, but they're kind of shrunk in because now we're looking at a longer length of time. So a shorter than usual pause duration following a shorter than usual with a following shorter than usual eruption as well. So that's that curiosity of them coming in now on Mondays and Tuesdays for the first overflows, and on Tuesdays primarily for vigorous fountain onset. And so we've had 20 episodes. Of those, 9 of them have had high fountaining starting on a Tuesday. So pretty interesting how that worked out. Our original eruption back on December 23rd began on a Monday, and we've had about a 1-week cycle. And so that's put us, it's had variation, of course, there. You can see there's quite a bit on Monday and Wednesday as well. But the further away from these central values you get, the less of these events you actually have, right? So pretty fascinating to look at that. So if you happen to be trying to come and catch one of these, you would probably book a ticket that would keep me here from Monday, Tuesday, and Wednesday if it was me, right? Gives you the best chance there. All right, so a little bit more to move here. We mentioned this map before, but through episode 18, we can add this. We know that we had 87.5 million cubic meters here, and we added 2.5 in 20 and 3 in 19. So that puts us up to 93 million cubic meters there. So I'm not sure how many billion gallons that is, but I'm going to guess it's about 25-ish billion gallons. So because through 18 episodes here, we had 23. We're averaging more than 1 billion gallons per episode, right? And so even with slightly lower than average values, you would expect to be we'd come past 25 here. I should do the math at some point and report. So that means that when we compare our eruption volumes of our current eruption here, which has been going on 134 days through episode 20 here, to our other eruptions since 2020, you can see that we are still shy of the total maximum volume we got in the September 2021 eruption that lasted over a year. But we've gotten there in much less time, perhaps less than half the time here, right? Almost 1/3 the time. And in that time that we had similar to this one for the first eruption back in 2020, you can see we achieved much less output compared to what we have now in a similar amount of time. So well, at this pace, we'll keep going and see how long it takes us to, if we can reach this maximum and pass it there. And so for fun, I've added on here the last few episodes, episode 18, 19, and 20. So for these, the duration I'm putting on here, the high fountaining phase duration. So you can see they're all just fractions of a day. But when we look per episode, the full cycle ends up being about a week in time there, right? So that is the volumes seen that way. And then if we look at the effusion rate, that's when we divide the volume over the time. You can see that we're not having outrageous averages here, 8 cubic meters per second on average across the whole eruption since December. But that includes all the pauses as well, right? All the time in between not putting out lava. And so even then, you can see at 8, that's ballpark of what we saw on a southeast rift. About half of the southwest rift. The southwest rift was so short that it likely would have tailed off to a lower value also. It just only lasted a few hours, so it didn't get a chance. So it's still the same ballpark here. Not quite as much as that September or June 2023 eruptions, but higher than the previous eruptions of the summit prior to that one. And the long-term average at Pu'o'o during that whole 35-year eruption was about 4. So we're double that here as far as our rate of output currently on average. But that said, during those 4 or 8 hours, they are measuring values around 140 cubic meters per second, right? And then that is then averaged with the 0 over the whole next 5 or 6 days, and that gets you to the 8 you see there. So pretty amazing era here in Kilauea with this much lava coming out at this fast a rate with this kind of cyclicity. This is really a phase of this volcano that we should treasure and remember for the ages here, right? Just like the era of lava flowing to the ocean was something we really value when we saw that was really unique and sustained. It wasn't going to last forever. And now we don't have that anymore. We have this, which is a different flavor of cool and interesting here. So that is the graphs we have to share. We do have some monitoring signals to step through before our break here. Last few things to look at. So here is our tilt for the last week. And we see, because we had 2 episodes in the last week, there's the deflation from episode 19 and the recovery in between, and deflation from episode 20 and a recovery we've had since then, right there. Earthquake counts don't really match that much there. You see they're still all fairly low, between 35 and 5 earthquakes, or really 15 earthquakes per day there. So pretty low values, and kind of distributed evenly in the shallow and deeper areas here. So nothing really noteworthy to note with the earthquakes. And there's our area map once again. So at the last month, here is 20, 19, 18. And you can see that following 17, we had that longer buildup here. So there is our pace, a little bit longer at the start of the month, and here more frequent towards the end of this last month here. And what you can see more closely here is that big drop we saw after 18, a long recovery. 19 had a small drop, short recovery. 20 also had a small drop. So you may also have another short recovery of this 3 to 6 day fashion, right? So there is that month tilt. That's the Wikahuna station. Sand Hill shows that same pattern. And we'll move past the earthquakes here. There's nothing really to highlight. And we've looked at the 3-month tilt before, and beyond these little patterns comparing to more recent cycles, we had seen somewhat of this. If we try to connect the tops of these peaks, right, that's where the threshold of where this is failing to cause the high fountains or gathering enough gas pressure to cause the fountains. You can see we're north 17. It looks like it was coming down overall, but recently, maybe slightly down, but it seems pretty flat here. It seems somewhat stable as well. So it seems like we should be back on pace to where we can anticipate where these cycles will occur. And with that, we'll worry about the complications of what happened over here, right? Getting further from this most unusual episode thus far, episode 17. So earthquake counts have really been quite low after December outbreak. Here we are, earthquakes per week quite low. Our summit GPS, as we mentioned before, in its quasi-equilibrium, expanding in the intervals in between episodes and then contracting during them very quickly, very similar to our tilt graphs here. But on average, you can see there, it looks like maybe it could be slightly extending, getting slightly further apart over the course of this sequence here. It's been 4 months. But if we take this a little further, I'm going to pull up our 2-year GPS plots here, which we don't have a whole lot, but we have a few around the summit area. This one is at Byron's Ledge. And so this plot, in case you have not seen this, is now 2 years instead of just 1 year. So it's kind of shrunk in more than you'd expect, right? Where the last plot was just this right half. We have a panel at top, which is the east-west component, north-south component, and we're going to focus on the up and down component, the very bottom plot here. So Byron's Ledge, which is in that southeast part, eastern part of the summit, you can see since December has actually been pretty stable, but if anything has been dropping down in elevation, maybe a little dip and come back up here, but whatever that was, it's still coming flat to down in elevation, right? So actually perhaps losing more volume than we can tell from the GPS or from the tilt, right? But perhaps expanding, like the crater growing as well, being pushed, but it's not growing in height, but growing in breadth as well, right? So that's Byron's Ledge in the east. We look at the outlet in the south, just this up and down component once again, and there you can see a steadily decreasing line. And so you look at this and say like, oh, look, it's not going down that much. We have to consider that this is a 2-year plot, and over 2 years there's been a bigger range of change. So let's look at the scale here. This shows meters, and it shows 0.2 to 0.4. So that is 20 centimeters in between those two lines right there. 20 centimeters, that's a good distance there, right? So if we look at what's happening here, we're dropping down similarly, maybe 10 centimeters, somewhere in that ballpark, right? So you're talking about maybe 4 inches or so. The ground has dropped in the south part of the crater over the last 4 months, dropping on average an inch a month-ish, something like that. So that gives you something more tangible to how the volcano is behaving, maybe sinking down at the summit, while we see it also expanding, contracting, and on net ending up slightly wider over time, even if it is slightly lower there. So this is a little bit of the detail of the pattern here. Further down on the Middle East Rift at Pu'u'u, those little variations seem to still be just little detours from a long-term pattern of deflation here. So rift zone is still contracting. There is no magma from this current eruption having to go over there. It doesn't need to. It needs to build pressure on the summit and come out there. That won't last forever, but for now, all looks well on the Middle East Rift Zone. So those are our monitoring signals here for this week. And with that, I'll pass it to Lou to do our community corner. Ready, Lou?
I am ready.
Your mic sounds a little low, maybe to me. Maybe it's just
a little low. How's that?
Try again.
How are we there?
Yeah.
Okay. Let's get this off there and get this up there. All right. You sticking around? You can take a break?
Yeah, I'm here.
All right. Let's do this. Dano, are you ready for me? Under 400 words a minute, Dano. All right. Up at the park. We're going to start there tonight. As we know, there's construction. That's probably, other than the episodes that are happening in the caldera, the construction is the other big news that's happening up there. It's been quiet somewhat for the last 2 weeks, but they're about to ramp up again. So if you're headed to the park for the next episode, pay attention when you come to the gate, because it is pretty much one lane at times. You'll see a sign that says merge right, lean left, just go slow, and watch out for construction. Our visitor center is no longer there. If you haven't heard, for the last several months, it's under construction, part of a 2-year project. The new one is up at the Kilauea military camp. It is now the Kilauea Welcome Center. So just past the original visitor center, and keep driving, and you'll find it. There it is right there. On your right-hand side, look for those cones. It's not a parking area. That's to prevent you from parking so you don't run over any birds or wildlife or cause any accidents. You can keep driving and you make a right into the Welcome Center, and the parking is on the back behind where the new HVO is being built. So it's a good parking lot back there. It's great access because it's right across the street from the caldera. You can go to the Welcome Center right there, check in there, ask questions with one of the rangers, see what they have going on up there. I'll talk about what's happening at the park in a minute, and then walk straight across the street and you're at the caldera. It's a very quick walk. There is limited water supply. Bring your own. There have been some recommendations that you can drink from the sinks. That's up to you. I'm not going to make that call for you, but I would bring your own, especially if you're bringing pets and children. They will have water bottle filling stations available soon. Waikahuna will have one. They do have stores. Volcano House has a store. The park, Welcome Center, Kilauea Welcome Center has water there for purchase. So just going to have to plan ahead on that one. There are all your lookout areas. There are no really bad places, and they're getting better. They're getting better as the caldera floor rises. More parts of the floor are easily seen from different parts, whereas a couple months ago it was difficult to see from Kilauea Overlook and down towards Volcano House. Now viewing is starting to open up towards that way. We had a little something happen in the park this week. Strong winds knocked down large ohia tree blocking Mauna Loa Road until the park staff cleared it up. It kind of brought to my attention to remind everybody, if you're going up to the park, pack a few extra things. Make sure your cell phone is charged. Bring some drinking water, as I just said. Bring a flashlight, a blanket, a thermal blanket. I know a lot of you like to bring the hotel towels. Maybe one upgrade from that would be good. And make sure you have food with you. This road here, depending on where a tree goes down, there's koa trees all up there. And if the windstorm hits, then you may be stuck for a couple hours till they can get to you. And there isn't always cell service up on that road. How am I doing, Dano? Am I okay for you tonight? All right. I got to check. The Kahuku unit has an event going on. It's Kahuku Pit Crater and its ancient forest. We have filmed these down there before. Ecologist David Benitez returns to share his experiences in the natural Hawaiian plant sanctuary that is the Kahuku Pit Crater. This is not David actually going down the mountain or down the cliff there, but this is actually the crew going to work. David led the team that rappelled down its 150-foot vertical walls into the crater to inventory and collect plants. It's going on this Saturday, May 10th from 9:30 a.m. to 11 a.m. down at the Kahuku Visitor Center. That's not in the main park. That's down past Nalehu as you're going to South Point, mile marker 70.5 on Highway 11. It's a 90-minute presentation. Every one of the presentations that I've gone to at the Kahuku unit is always shoulder to shoulder. It is always packed, partly because it's not as big as the auditorium and up at the park, up at the visitor center park. The other is that they don't get a lot of events, and so the Ocean View community comes in, the Nalehu, Kau community, all come in for these. So get there early if you want a good seat. Life on the Edge is still going on. It's happening pretty much all year. There's 4 times during the day that it's going on. You can learn about Hawaii geology, culture, plants, and animals. It's a great time to ask questions. I know you guys are asking questions here in the chat, but it's also good to get up there and ask these rangers some questions. Go into the Welcome Center, and they can help you with that. And we just did a collab with Haka, and it was at the Maku'u Market this last weekend. We have another one coming up on May 18th. Dane is not with us tonight, but he spoke. We also had the Civil Defense Administrator, Talmadge, was there. Cindy Preller from the Pacific Tsunami Museum there. And the Maku'u Market, they were also speaking there. If you are around, please come see us. Philip is talking on the 18th, right, Phil? Yes, Philip is talking on the 18th. If not one of us are talking. We have a bunch of different presenters. There's lots of giveaways that are going on. It's a good time. May 18th, 9 a.m. to 1 p.m. It's a Sunday at the Maku'u Market. Also being live streamed, so you can catch it there online. The Tsunami Museum.
Actually, will not. I will not be there because we have the Hub Summit happening as well that day.
Oh, that's right.
Yeah,
that's right. So it looks like Dane.
Divide and conquer. Yeah.
Divide and conquer. That's us. All right. Let's see, new chapter at the Pacific Tsunami Museum. Like I keep reminding everybody, get down there, get educated, learn the stories of the survivors. It's a great place to truly learn about some history that doesn't get enough publicity out there. So I encourage you to go to the Tsunami Museum on the weekends, 10 to 2 p.m. And if you are not on our email list, this is a good time to do that, hveri.org/subscribe. And you can pick either our general email list or our volcano eruption notification, where we'll send out a notification when an episode is beginning, as well as when the fountaining starts. Or you can sign up for both. And our newsletter is about to come out. I was holding off until, I'll show you in a second, until we had this night right here, and that is our Philip Ong, and doing his elephant toothpaste experiment at the Keanapoko Elementary School last night. So there'll be a little write-up about that and talk about our volcano toolkit and our youth development program. You guys know we do the volcano education. We also do digital resilience, and we have been building for the last year our youth development program. So we have a lot of fun with those right there. And I didn't see that. Philip, you got something?
Yeah, so I was just going to say that we are going to also be restarting our community survey. And so maybe we can drop a link in the chats here. And if you guys who are, especially our dedicated viewers, could go and fill us out. If you filled one out before, we ask you to please fill it out again, because we're trying to capture our progress over time and see what's changing over time. So it'd be really useful, even if you've done it before, to please do it again. Look for the link in the chat. We'll be putting a post on Hawaii Tracker at some point soon as well. And we appreciate you guys' support that way as well. So if you're, let's say, wishing you could help us out in some way without having it be financial, this is a great way to do that as well. I really appreciate it.
Absolutely. Yep. I'll put that in the chat as soon as we get wrapped up here. You'll see that go out to across all our social platforms. You only have to fill it out once. So just because you see it pop up again, is we're just trying to make sure for the next couple of weeks we get everybody on there. And Philip, would you like to take this part?
All right. Let me find the right mahalos to put on here, right? We're going to say our thank yous to all of our partners here. So that includes from the county, the Puna Strong program, which we currently have 2 grants through there, as well as the Vai grant and aid program from the county. We appreciate them for that as well. And finally, Kilauea Recovery, wrapping up here pretty soon, but appreciate those guys too. So we will at some point be sharing our results with you guys. We're writing lots of reports for our grantors about the progress we've made, which is why we need data like the survey we're asking you guys to fill out. And we can share that with you guys, because it really is, I suppose, rewarding for us to see that there is good impact that we're making out there. So really appreciate you guys staying tuned. We like to say that you're our little army, that when the time comes to proper information, that you'll be the ones to help us do that. So here's our thanks. Kilauea Recovery, County Hawaii, Atherton, Give Bag. Here's our supporters: Obi-san, Desiree, Skag, JW, Lisa, Susan, Kathleen, Nathan, Katrin, Robert, Robin, Roylan, Don, Cindy, Linda, Catherine, Amelia, Ronald, Rebecca, Lori. I missed
nice. That was good. That was good. You don't get any practice during the day. Since I'm the one that writes it, I get a little more practice. You did pretty good. Pretty good.
I could have zoomed it in more also, so it was easier to read, but next time. It's a lot of stuff on the screens all over the place here.
And I wasn't going to slow it down for you either.
No, that's fair. That's fair.
And thank you to all of our online donators on YouTube, as well as our webpage, hveri.org. You can donate to us. We have a $10 super chat from Don Stringer. It says the episode 20 fountain was officially 601.75 feet, highest without going over. All right. Let's see. We also had, we had another one pop in here. There it is. Norm from Hawaii, a $20 super chat. Thank you very much. Appreciate that. Robin over on our hveri.org site, a $21.12. Thank you very much for that over at hveri.org. That is the best place to donate to us. We are a 501c3 community-based organization, and we appreciate all the time you spend with us, all the donations, and yeah, thanks so much. Philip?
All right.
You want to
Should
take
we
some
do
questions?
a couple questions here?
Yeah. All right, here we go. Let's see here. Here's one for you from Victoria. Does SO2 reach mainland?
It seems like it does fly over top of it. I don't know if you would detect it on the ground there, but let's pull up our windy satellite map here. Let me get my thing back on the screen, Lou, if you can help me with that.
Oh, yeah. There you go.
All right, so here's windy.com, and there's our patch. And so right now, I don't know if you can quite see this little white arrow is moving around. The wind direction is coming this way over here. It's going that way over there. There's a little eddy right there, but then it kind of comes off this way, right? So presently, the winds are not favorable to the stuff moving towards the mainland, but there are times certainly where we've seen it do that and wrap all the way over. So maybe since this has been going on 4 months, some of our gas blew over and got merged into some of the stuff over here. I couldn't tell you without tracing it back further, but so what I can say is it can reach there, but presently it doesn't seem to be doing that just because of the wind patterns. Good question, Victoria.
All right, here's one of the questions that always comes up, and I don't know if you're going to have the answer to this one. How long before the caldera is full?
So that depends a lot on the rate of lava coming out, which is why I'm trying to measure these volumes coming out here. So I don't have an answer as far as how long it'll take at the current rates, but all of our estimates over time have been years. Have been the answers, some number of years. So I'll do this again soon. Because now we're getting more consistent rates being reported for our episodes, I can probably get a better handle on it as such. But I can tell you that of the collapse of 2018, in volume, we've refilled about 1/3 of that volume. So we have 2/3 of the way to go still of what we lost in 2018. So if you're thinking, okay, the caldera is mostly full, it's going to spill over pretty soon, that is actually not true. It's only 1/3 full of what it was before. It just looks fuller because that inner part is steeper and deeper, and it flares out at the top, and it's really, really wide in that pit to overflow onto the previous caldera floor, which is not even filling the whole caldera. For that to happen, you'd have to fill it even more than that and spill over the outer caldera walls, and that would take years of some number. So it's a great question, Norm. I calculate it from time to time. I should try to get back on it here. Now that we have better data, I'll try to do some projections for one of these next weeks here.
And one more here from Dawn. What is the current altitude above sea level of the caldera floor?
All right. Here is the most recent map we have from January 10th, actually. So it's a little bit dated, but this gives you some idea here. At this point in time, that elevation was between 900 and 1,000 meters above sea level. So I'd say we're probably in a range of 975, 980 now is my calculation. So just shy of 1,000 meters above sea level. So what would that be here? Maybe I can do a quick calculation. Just let's call it 975 feet or meters equals 3,200 feet. So that is my best educated guess at present as for the elevation of the lava surface there, right? And as we know in this cross section here, that's this level down here. The caldera wall on the northern side is quite tall, so it's all the way up here. This gray line is where we were in 2018 before the collapse. And so when we say that our volume is missing, it's all this stuff in here, all through here that's missing, all the way to, if I scrolled over, all the way to there, as far as it collapsed. So about ballpark in there, right? The summit of Kilauea is about 4,000 feet, maybe about 1,000 feet below this uppermost point. at 3,200 feet or so is my best guess for the elevation of the caldera floor, the lowest part right now.
All right, I got one more for you. It just came in. Kind of goes with the filling. Question from Paul Todd Music. With the weight of the lava on the crater floor, could the crater floor collapse?
So it seems tempting to think of all that stuff as like filling a space that could collapse into, but really there's no hole down there for it to fall into to collapse in the first place. That's really the problem with it collapsing due to its own weight. What we saw in 2018 for the collapse was all the lava drained out from way underneath this, out the rift zone from below, to create some space, and then we had a collapse after that. So, but for it to drain, we had to actually leak it out of the ground and erupt it down in the lower east rift zone to create the space to cause the collapse. So that's typically when we get the collapses, is when you have some kind of flank eruption that withdraws magma from the summit area. Then the summit can collapse after that happens. And little collapses, this is the biggest one we've seen in the historical record, but geologically, the whole caldera is collapsed as well. So there certainly have been bigger collapses than we witnessed in 2018. But we believe almost all of them are from lava draining out the flank miles and miles away. And then that creates the void. And then that's when the weight of the stuff on top comes into play finally. So it does matter, but it has to actually have a space to fall into. And a big earthquake could do it more quickly, perhaps. You can like maybe move the flank, open some pathway, withdraw a bunch of lava, then you might have a collapse as well. But just by itself, the weight is not enough, if that's an answer to the question. We do see settling of the crater floor because of the gases that are released. It's really frothy stuff. So it does appear to kind of settle and lower in elevation a bit there, but that's because of the gases are bubbling out, and it's kind of, just, I don't know what the right verb is to use here, right? But it's shrinking down there, contracting and lowering the surface.
All right, that'll do it for our questions. I do want to mention Robin, who donated over on our HVERI.org website. She sent a nice message with that, and she says, I just watched the whole series about the 2018 eruption on your site. So well done and absolutely fascinating. So thank you, Robin, for that. We do have all those videos on our YouTube, so check it out. Thanks again, everybody. And Phil, it's all yours.
All right, thank you. And so let's turn to our Kilauea observations to mostly wrap things up here. And we will start with some time-lapse camera shots here, animations. So here is our B1 camera. And this is that day and night version, that first flow, that flow to the north there. Second flow to the south here, that was episode 20, this last one. And then most recently, just overnight last night, we see ooze-ups. Where'd it go? Right in there. And there's our ooze-up flow. There's our 2 spots of glow from our vents in the far distance. And I'll rewind it back, and you can see that's not the same area as we had the lava flow extent previously. So that's how far that goes, and our ooze-up is off to the right of that. So pull it back to episode 19 here. So between 19 and 20, you can see there's more of those ooze-up flows as well. So let's pull it all the way back. There is 19 with that big flow on the northern edge of the caldera there. You see it's getting pretty close to these line of buried cinder cones from September 2023, but not quite there. Maybe close enough to perhaps put some weight on this crust, and if it's not very thick and it can deform, maybe that's a way that the weight of lava can influence things, right? Maybe that's helping cause some of these ooze-up flows nearby as well. It could also be injecting beneath from way further over. I believe that's happening as well underneath all of this from the vent area all throughout. But what you can see is here between 19 and 20, during the daytime, it's hard to see right in here. There's a little flow that pops up right in there, the daytime, and then in the evening time continues going And then by the next night, you don't see it much anymore. Well, there's a few little toes still. So that's the fascinating part there, is with these ooze-up flows. There was also, we'll see in a photograph coming up, the USGS reports they saw an ooze-up flow sometime in here. And I think it's this little patch of gas right in here, close to the vent, way on the far side of the crater from this camera, so we're not going to see it very well. But they have a better image to show us there later. So there's that full last week then, with that fountain phase of 19, some overturning, ooze-up flows, glow from the vents in between, build up to episode 20, and there it goes. More ooze-up flows after 20. And here we are today. So looking at just a daytime view here and animated quickly. I think I got it on loop here, right? So let's zoom it into some of these areas and look at the vent area here. You can see this is just one image from noon for the last week or so. So you can see there's a little bit of change in the shape of the vent. The flow area nearby, you can see flashes and changes quite a bit as well. And so those flows that come out and cover, you see these patches of dark, that's the flows from before this last week, and the silver stuff comes over top of it here in the foreground. And so in the center, you can look on the edge of the crater too. You see some onlapping of the most recent flow here. And what was most fascinating to me, as I pointed out in our summary, is if you come here to this foreground at the very bottom of this image, all this stuff, even over here, this whole rim right there, that's all of this you can see to be rising. And because we had the first day of this animation, episode 19, the last day, episode 20, most of this is the time in between them during our pause. So during our pause, we're injecting lava under the crust, which is something we've seen before, but not so much from this camera. Our other camera, the B2, was placed over here, in this area over here, and we were watching the crater floor uplift in this area over here previously. So we might still be seeing some of that happening. It's hard to tell with this resolution right in here. Maybe there's a little bit of settling after the flows to me right in there. But what we're seeing is in this furthest east section, like there, this very bottom part here, I just really zoomed it in, right? So this lighter gray area over here is the down drop block from 2018 that has not been covered in lava since. So this is the edge of our current flow. And as we showed you in our cross section, this whole eastern edge of the crater is shallower. It's not as deep as that center portion. And it has not always shown this uplift like we saw in the center. But by now, it appears we've thickened enough this eastern area, right? And one of the points of evidence to that is we only have 2 cinder cones from September 2021 still left. All the other ones have been buried under lava. There's a top of one right there, for example. So it's getting thick enough that perhaps you can have injection all the way to this eastern edge of it, where you really can see the ground rising on there. And let me, just for the sake of change here, let's speed it up. Let's make it twice as fast. Maybe that makes it easier for some of you guys to see this little wiggle happening down here in the foreground. So I see it happening. I don't see it here. I see maybe an edge right there. Something like this is where I see it moving. All the way over there, it's moving over here. And to this direction, I see it like that. Everything on this side is moving up during the last week. So that's one of the most fascinating things. When we look back at this pattern of the sequences and episode 17 being unusual with lower fountains, and we have now the last 2 episodes also had not as low as 17, but lower than average fountains as well. What could be going on? And to me, the biggest variable we have not accounted for here is this whole reservoir that's underneath this crust of a lava lake. By now, this is a huge volume of lava underneath there. Whether you think of it as a jelly donut, or I prefer the stack of pancakes with lots of syrup in between, and maybe we're like drowning with too much syrup and there's less pancakes, so there's some version of that in there. So you have layers of more solid stuff, but you have these pathways of liquid that can move through there as well, is how I think of it, right? So you can get stuff all the way across here, injected between some pancakes, and then it can ooze up at the far side somehow or another. And with this crater floor being so massive, so huge, that volume is not insignificant. And it's like trying to, I don't know, blow up like a tire when it has a leak. It just keep you can't pressurize it the same way because it keeps going somewhere else and leaking out over there, right? So that's one of the possible variables that could be influencing the changing of our pattern to make them longer, lower fountains, that kind of thing, right? And then beyond that, there's also some variation within the vent area itself, where we're seeing this interplay between sometimes it's a south vent, sometimes it's a north vent, one and the other. So there's clearly some geometry that's changing over time underneath those vents. Like maybe one's getting more blocked, other one's not able to, doesn't have maybe quite as straight a shot to come out, so it can't fountain quite as high because of the pressure. Is just something funny like that might be going on. Certainly it's changing a lot. You can see from the surface, and you would imagine it's changing beneath the surface to some degree as well. So that is our B1 camera, our replacement view there for the crater uplift. And so we'll turn now to the S2 camera, back from the end of April, precursor to episode 19. There is those overflows, degassing with trade winds in between, glow constant from both vents throughout all 3 nights, but a shorter than usual 3-day pause before activity comes back to the north vent, where it starts overflowing. South vent puts out that tongue as well. There's those pistoning cycles before the high fountaining phase comes in right here, including that one flow that poured into the south vent. Maybe you caught it there. Pull it back if you didn't. One more time. There's lava flowing down into the hole from above from that fountain. We haven't always seen that because they're usually both putting lava out at the same time. So that was the S2 camera. And we showed this before, but there's, or maybe not this one. This is a V1 camera, episode 19. The precursor activity, the fountains, the in-between time there. I'll play that one more time. Some spatter beforehand, glow from both vents. Here comes the pistons of lava and the overflows, and then the fountains. And then the end of the sequence and dimming of the flow field there. Episode 19 from the V2 camera. And there it is, those overflows, and then that big movement of lava. And so this is interesting. We saw the lava pouring out and then filling this intermediate pond area here and spilling over from the edges. And after the sequence ends, you can see this surface here contracting as well, with the gas escaping and the whole surface lowering it. I cut out one night in the sequence here at the very end so you can see it a little bit more clearly. So let me see if I can play one more time to you guys again. There is the pond right there. Maybe see it lowering down a little bit relative to this foreground right there. So that's the episode 19 from the V2 camera. So episode 20, V1 camera, similar pattern, pistons, overflows. There's a fountain phase, and there's a shutoff, and an overturning, draining of the crust down in there as well. One more time. You can see the south vent flows coming out the background here as well. There's our ponding, and right in here, contraction, degassing, overturning, and pow. So different angle, V2 camera, episode 20. Same pattern, overflows, a little bit more flashy because they're a little shorter there. North vent, more steady, and then short and sweet fountaining phase, only 4.5 hours long, and completely dark from that view across the crater after that. So those are time lapses. We'll show you guys a few of the images USGS has released. They released a set on May 5th for episode 20. So we have images for here. So there's that first flow from the south vent, 10-minute cycles. So 5 minutes apart images here showing more constant from the south vent, looks the same. The north vent looks a little emptier and looks a little fuller right there. And that's, you saw that already in a time lapse. Zooming into the south vent there, the more passive ooze up of lava pad and then running out. And they noted spatter being thrown only about 10 feet in the air, 3 meters from the south vent during that precursory activity time. And then here is the north vent from that upper crater rim during one of these rising cycles. Looks like it's going to overflow there at some point there. Those fountains in there, the dome fountains, as they're calling them, approximately 20 feet high, about 6 meters. And that's that first set of images from the USGS. The second of 3 here, episode 20 images. So this is all during that 4.5 hour window that was all in the evening. Here they note 500 feet, 152 meter fountains. They note that the wall behind the vent here is been measured at 492 feet high, 150 meters. And you can see that the top lava flow, top bit of lava here is just above that right there. So that's their estimate there of 500 feet. And remember that distance between the bottom of the fountain and the crater wall has changed because this thing's been growing and getting higher over time. So that distance has been shrinking. And so now when it reaches the crater rim, it's only 500 feet as opposed to before. It might have been 600, and before it was more than that even. So a photo by Katie Mulliken. Mahalo for that. And a nice wider view there. There's that fountain spilling over the north vent, flooding into this upper perched area. And then where it overflows that, you see this cascade of lava spilling over and more exposed with the bright colors shining through. And then spilling out to the flow front over here, advancing to the west, to the east, I should say, to the left of the picture there. All right, then another view of the north vent fountain, with overflows there. They say here, gas emissions are elevated during these events at a range of 40,000 tons per day. The daily update said as much as 50,000 tons per day. So those are both consistent. And here, the last image, I think, yeah, last image here of the set of that fountain from the north vent. So here's our third image release from just yesterday during a pause after episode 20. So telephoto view into the north vent here. And I liked how this photo by Natalia Deling is pointing out the different textures. The darker, rougher lava on the right are the spatter-fed flows. So this is lava falling from the air and it's landing in these very chaotic fashion here. And then this more silvery, smooth lava, that's the lava actually spilling over as sheets from the vent over top of the ground. And so you see this different texture right there. And then there is all the gases emitting, mostly water vapor. Of course, there are some sulfur components as well. Keep it moving here on May 7th at about 13 hours after the end of episode 20. And so May 7th, 13 hours is just yesterday, 13 hours after the end of episode 20. They noted a lava ooze out north of the north vent. They noted ooze outs have occurred despite there being no lava coming from the vent itself, but changes beneath the solidified crater floor, resulting in material oozing out there. So that's fascinating. This is the one I was referring to before. We don't really have that great a view anywhere else, but there it is. And not connected to any of these flows, and does not look like it's necessarily one of these overturning flows from one of the ponded areas either. So really interesting to note that. We haven't seen so many ooze up flows on this western part of the crater floor near the vents yet, this eruption. We have seen them in previous eruptions of the volcano. But maybe as the whole lid is raising higher and higher and higher, we now have more of that recently fluid interior that can act as a pathway for the lava to reach those further away areas. And what else they've put out is these views and measurements of the vents themselves. So they've looked into the north vent here, following the end of the fountain. So that's where that lava was shooting out of, was that hole. The inner hole inside of this bigger bowl. See that bigger bowl in there? And so they say here, the conduit itself is approximately 66 feet across, 20 meters, 20 yards, right there. Within the larger vent, which is approximately 60 meters or 60 yards across, about 200 feet, with a distance of 30 feet in height from the top rim to the vent itself, about 9 meters, as listed there. Another great photo by Natalia Deline. And here is that wider angle view of north vent and south vent. They can't measure quite the same way from here, at least, right? So, but how they're looking in and measuring that distance from this point of view here. So that's the last photo release image from the USGS here. We'll just take a quick peek into our cameras. Here's a V1 camera live. See active degassing there. But nothing else currently happening. And there is our V2 camera. This has some bird flyby, looked like. Looks like maybe the winds are changing a little bit, perhaps, but maybe that's the most visible thing here to me. So those are our observations here. We have one more thing to do, which is our volcano watch this week, which is from the USGS, 20 episodes and counting. Lava fountains continue in Halemaʻumaʻu. And so they recount many of the patterns we've been discussing here ourselves and put out this photo compilation of all 20 fountains. Not all the same view, so maybe you can't compare exactly like the heights or whatever, but it gives you a distinctive image of each of these 20 fountains that we've had so far over our, how many days was it? 130,
37.
30, well, to now, right? 34
Yeah.
through episode 20, right?
Right.
So yeah, that's Volcano Watch this week there. And we'll wrap it right there, Lou, with any more commentary, questions you may have.
I do have
Anything
another
come up?
question. I do have one question in here. Here it is. From Chad. So the flank in the entire landmass and the rift zone is more on the surface?
So the rift zone is the edge of the flank all the way down to the bottom of the flank, which is roughly 8 or 10 miles down or so, right? So that whole, so the actual pathway of lava in the rift is shallower for sure. And there's debate about the deeper pathway, whether that actually accommodates magma movement as well or upwelling from below. But as far as a structural change, a structural barrier, the south flank is bounded below with the old seafloor underneath the island, and on the one side by that rift zone, which is a structural, it's like a fault zone really, right? And a rift zone is basically like a fault zone that magma is moving through. So then you have this whole question on Kilauea, like what's more important at any moment in time? The USGS has written it before as who's driving the car? Is the magma building enough pressure and pushing into the rift zone and causing the south flank to move itself? Or is it gravity pulling the south flank, making space, and then that pulls the magma into the space? And both things have happened in the past. And that's how they describe who's driving the car at any moment in time. Right now, it seems like it's the magma is driving pressure into the summit, and the south flank seems to not be as involved. It is still moving, but it's not as active as we've seen it at other periods in the past. And that's something we hope to explore more in the future, but that's, I would imagine, an active area of research as well among the scientists. And so at some point, we hope to get maybe one of them to explain it to us, since that is a really interesting thing there. Good questions.
Yeah, right on. All right, everybody. Thank you very much for joining us tonight. We appreciate all the super chats and donations on our website at hveri.org. And tune in next week. Tuesday is probably going to happen for the next episode. We'll be back on live Thursday night, unless something
extraordinary happens, tune back in. Take a look at our social pages. We do post on a daily basis of updates and things that we're doing and what's happening with the volcano and other events that we're intertwined with. And Bill, you want to take us home?
Yeah, and so along those lines too, the Facebook group Hawaii Tracker is a place where we really crowdsource a lot of this information, right? So not only are we sharing the USGS stuff here, but over there you can see all of our own community, all of you guys can post your own images and stories and share all those, right? And that's really valuable too. So sometimes we have a chance to compile and share those. Sometimes we don't. They're always there all the time. And so if you're not part of the group, we do encourage you to go and join it just for that reason itself, right? And then come time, if there's any disaster, we do activate that into the disaster mode and use that to communicate and coordinate our whole communities so we can be efficient and avoid any kind of ill consequences in the style of Lahaina, for example, that we saw in Maui a couple years ago. And so that's how it all fits together. And so we're excited to keep doing this for you guys to improve preparedness on our island with our educational content, our outreach events, all of it here, all of our trainings we do. We help train social media groups, try to get them in the same standards, right? So we're all able to help our local officials as much as possible and in a trustworthy, verifiable way. All that stuff's important. So mahalo for all your support from our nonprofit HVERI, the Hawaiian Volcano Education and Resilience Institute. So that does it for us this week. Appreciate Dane's support, even though he is not here live with us. He did help with production on the back end before all this. And mahalo to our ASL interpreters as always, Carrie and Dano. Appreciate you guys as well as our entire deaf community. And Luatore. I'm geologist Philip Ong. Until next week, aloha everybody.